Hi dear students and viewers, in this video we are going to discuss about the one of the short answer question in the chapter of current electricity, and that is purely based on the application of combination of resistors. Actually, in previous videos what we discussed, we have to find out the effective resistance in series combination and parallel combination, but it is theoretical application. So very interesting question and very easiest question. So that is, look here, the question seems to be very big but answer is very simple. A student has two wires of iron and copper. A student has two wires of iron and copper of equal length and diameter. He first joins the two wires in series and passes an electric current through the combination, which increases gradually. After that, he joins the two wires in parallel and repeats the process of passing current. Which wire will go first in each case? That is the question. A student has two wires. One is made up of iron and next one is made up of copper. First he was joined in series, these two, and given to some battery, and he was increasing the amount of current in the circuit. Then which wire will glow first? That is the question. And again, in the second part, these two wires are given in parallel. In this case also same process. Two wires are connected in parallel and it is given to battery and sending the current. In these two, which wire will glow first? Here already we know that what is Joule effect. When there is any wire, clear, that should be given to some battery, clear, and that should be given to some external resistance like this. When the current is passing through the particular resistor, the amount of heat liberated, that should be equals to the I square RT, or H is equals to I square RT. When electrons are moving through a resistor or any wire, the electrons will make some collisions with the atoms of the wire. Then obviously the electrical energy is converted into the heat energy. Due to that heat energy, the wire is going to be heated. So due to the continuous collisions, continuous heat is developed. Due to that, the wire will be glow. Got my point, children? When any wire is given to battery, the wire has some particular resistance. What is meant by resistance? The opposition shown by the material to the flow of electrons, that should be called resistance. Every wire has its own resistance. Clear? When the electrons are moving through the wire, the electrons will make some collisions with the atoms of the wire. Then the electrical energy is converted into the heat energy. Due to that heat energy only, the wire is going to be gets heated. So already we know that when we are heating any wire or anything, water maybe, it is turned into some particular colors. So that is nothing but glowing of wire. Clear, children? That's why here the getting of heat of the wire is the continuous process until the electrical energy is completely converted to the heat energy. Clear? So that's why simply in this case you have to remember very simply, when the current is passing through the wires gets heated. So when they are gets heated, among these two wires, which wire is going to be glow first? So glowing means what? Nothing finding into one particular color other than its own color. Clear? So that's why here simply according to the question what was given, this is the one wire. So that is what, first thing is what? Iron wire. I am showing that should be having some resistance. Clear? And another wire is what? Copper wire. So now these two are given in series combination. Clear? So I am showing the resistance of the wire should be like this. Clear? And this is the what is copper wire. How these two are? These two are in series combination now. and finally the ends of the combination should be given to one battery like this. Clear? Then obviously the current is moving like this. When the current is passing through the combination, what you have to say? The current is passing through the same resistance. For example, this is I am saying R1 and this is R2. When these two are in the series combination, the current is moving only in one path. That's why same amount of current is passes. Same current is passes through the combination. Clear? That's why the amount of power loss, the power dissipated in the combination is given by the formula P is equals to I square RT. If you can take unit time, we will write P is equals to I square R. So here P is nothing but power dissipated. It is also called as power loss. It is also called as heat loss. It is also called as ohmic loss. Clear? So here what we are saying, the same amount of current is passes through iron and copper. That's why here I is constant. I is equals to constant. Then what write children? P is proportional to R. P is proportional to R. That's why here among these two wires, which has more resistance, which has more resistance, that will use the more amount of heat energy, and that is going to be glow first. That's why here already we know that the resistance of iron is greater than the resistance of the copper. R1 is greater than R2. According to this condition, what is the amount of heat loss or amount of power dissipated, that is directly proportional to the resistance. That's why the wire which has more resistance, that should be glow first. That's why among the iron and copper, iron is going to be glow first. Why? Because it has more resistance. It has more resistance. Clear, children? So this is in case of series combination only. You have to remember. If the same wires are given in parallel, what happen? Let us see. So this is the iron wire and this is the copper wire. Now these two are given like this. Clear? So they are given to one battery. So like this. This is again R1, that is what? Iron, and this is the copper. Its resistance is R2. Simply I am showing like this. Its resistance is R2. When these two are, how these two are in parallel, what we know, in parallel combination, the potential difference is constant. Potential difference is constant. But in case of series combination, current is constant. That's why here in this case, what right? Potential difference is constant. That's why in this case the power dissipated, what right? P is equals to I square R d square. The same thing will be written as P is equals to V square by R. Clear? So it is nothing but I square R into R by R. Then what do you get? What do you children? P is equals to I square R square by R. I square R means what? I square R square means what, right? P is equals to IR whole square by R. That is equals to what? P is equals to V square by R. Clear? So for parallel combination, the power dissipated, the power loss or heat loss or ohmic loss, that is given by the formula P is equals to V square by formula we have to use. And in this case what we discussed, V is constant. V is constant. That's what, right? P is proportional to 1 by R. Clear? So the wire which has more resistance, that should be having less power loss. Clear? And that's why the wire which has less resistance, that should be having more power loss. That's why the wire which has less resistance, that should be glow first. Clear children? Got my point? Here these two are inversely proportional. When resistance is less, power loss is more. When resistance is more, it is less. That's why among the iron and copper has less resistance. Copper has less resistance. Due to that, in parallel combination, the copper wire is glows first. Clear children? So in this way we have to understand the concept. Got it? So that's why you have to, I think so you understand this one. If you can understood this one, like, share, comment the video and subscribe to my channel children. In our channel we have all the intermediate, second year, first year topics and all the playlists. You have to once check it in that, so all concept will be covered. Clear? So thank you for watching.